Hello everyone, welcome to the notes for lesson 4, Isn't it Ionic? The guiding question for today is explain how to write names and chemical formulas of compounds with polyatomic ions, which we will cover in a second. For the do now, we're going to review some of the concepts that we've covered in the past. So name the following compounds. Remember that we start with the names of the two elements, so lithium and oxygen. And since lithium is not a transition metal, we do not need to use Roman numerals for it because it only forms one type of charge, which is the +1 charge. So that means that for oxygen, we're going to change the ending to IDE, so it becomes lithium oxide. Repeating the same process for the next one, we write down the element. Calcium is in group 2A. It is not a transition metal, so no Roman numerals. And so we follow that up with chlorine, that becomes chloride. Finally, we have Fe and N. Fe is iron. And is that a transition metal? Yes, it is. So that tells us that we need to put Roman numerals in. So I like to put parentheses and leave a space. And then we look at the N, which is nitrogen, that becomes nitride. And if you wrote like nitrogide on a test, I probably wouldn't take off points, but try and say it in your head to see which one sounds like comes off the tongue easier, because that's usually the one that you're going to write. Okay, so for the Roman numeral, what would you write in the Roman numeral spot? The charge of iron. And what is the charge on iron? It has to be +3 because what is the charge on nitride? -3. And you get that from the periodic table, right? Nitrogen is in group 5A. So that tells us it has 5 valence electrons. So it is going to gain 3 electrons to have the -3 charge and fill its outer shell. So since I have a 1-to-1 ratio, that means our charges should be equal but opposite, so that they combine to 0. And that was the rule of 0 charge. Make sense? Are there any? Okay, so then we would write the Roman numeral 3 in the parentheses, and that would be iron 3 nitride. Now on to notes for page 13. Please make sure you have your periodic table out, as we are going to add some resources to the back of it. Okay, polyatomic ions are ions that are composed of a group of atoms that have an overall positive or negative charge. There are a lot of them. We will commonly work with these 6, but there are more. You are going to be tested on these 6 specifically, and if you continue on in chemistry, we will grow these. And I also have ion reference sheets for when we do more, but with different ions. So these are the 6 you need to be able to utilize frequently, but there are more. So on the back of your periodic table, we are going to list these out. You will want to write down that these are the polyatomic ions on the back of your periodic table. And then we are going to write these in. You can also put them on, you will also put them in your notes on page 13. So OH, and that's with a -1 charge, is hydroxide. NO3, that is a subscript 3, so that's saying 1 nitrogen and 3 oxygen. That overall has a -1 charge. This is called nitrate. CO subscript 3, so 1 carbon, 3 oxygen with a total -2 charge. This is carbonate. Pay attention to the fact that that is a capital O. So that is not cobalt. Make sure you know that this is not the same as cobalt, which is a lowercase o. This is why capital and lowercase letters are very important. SO4 with a -2 charge is sulfate. PO4 is phosphate. Again, that is not the same as polonium, which is a capital P and a lowercase o. And finally, NH4 with a +1 charge. So it's a subscript 4, +1 charge, is ammonium. Okay, this is not the same as nihonium, which is in lowercase h. Okay, just make sure you recognize that those are not the same. Got it? Okay. Okay, so let's look at some examples of these. So if we have the compound that's going to form between magnesium, which forms a 2+ charge because it's in group 2A and loses 2 electrons, and sulfate, which is SO4, 2-. When we name them, we use the same naming conventions. So this would become magnesium. And then SO4, you would need to recognize that as a polyatomic ion and be like, oh, that's on the back of my periodic table, or remember that that is sulfate. So we would say magnesium sulfate. When we write the compound, we do the same thing as before, but remembering that this charge on sulfate is over the whole compound, not on any one part. Okay, so we have to make sure we identify sulfate as it's an individual ion. In this case, do the charges cancel out? Yes. So do you need to trade them? No, they already cancel, so you just need one of each, so MgSO4. You do have to write the 4 because that is part of the identity of sulfate. Okay. Are we good so far? So our next example would be between the 2 for tin with a 2+ charge and phosphate with a 3- charge. Okay, we're combining a couple things here. So this would be like considered to me a hard question or a hard like practice problem. So we do the same as we've done in the past. We name them the same way. So tin, is that one of the ones that forms only one charge or multiple charges? Multiple, so we know we need a Roman numeral. Do you know what Roman numeral we need? 2. And that is from the 2+ charge on tin. And then we name phosphate the same we would normally do. So phosphate. You just have to be able to recognize that the PO4 indicates a polyatomic ion, so the ending will be a little bit different. Some of the ways I remembered that is if there is a T, you need to remember that it is probably together with oxygen. And so you want to verify which polyatomic it is. Okay. From here, then, we can write the compound. So do the charges cancel out? No. So what do we do for that? Trade them. So SN, and then the 3 comes over here. So SN3, and then we have PO4, 2, because the 2 is going to come over here. Now, I need to make sure I can identify the phosphate in the compound as it's written. If you want to say you have 2x, but you're multiplying it by 2, but still see the 2x, what do? You put parentheses around it, right? Because if I left this 2 here as is, that's P with 42 oxygens. It's kind of impossible. If I instead distributed it and wrote this, it is a very different compound than phosphate. I do not see the compound or the polyatomic ion phosphate in this. Okay? So I have to protect the phosphate by deploying shields, some strange nerdy business right there, and then put the 2. So you put parentheses around the polyatomic when there's more than one, and then put the subscript you trade after. Okay? Makes sense? So one more example. So if we had 2 polyatomic ions, it follows still the same procedure. You first write the names, which NH4, if we look at our list, is the only cation that is a polyatomic ion. So this is ammonium. And because it's on that list, it only forms one charge, so there is no parentheses with, like, no Roman numeral. And then we have PO4, which we said previously was phosphate. That is how you name it. Ionic compounds, you just pull the names of the 2 ions. If the first ion is a transition element or forms multiple charges, so some of our post-transitions, you then need to use Roman numeral and write in the charge. For the second one, if it is a polyatomic ion, you need to make sure you're paying attention and writing the polyatomic ion's name and not phosphide, because that is very different than phosphate. When we write the compound, we check the charges. Are they equal? No. So what do? Trade. So the 3 comes over here, and there's an invisible 1 that's going to come over here. So I have NH4 and PO4. Now I need to put parentheses to protect the polyatomics. Do I need it, though, for the phosphate if I only have 1? No, I don't, because distributing that 1 doesn't change it, so I do not need to write that. I would accept both. The first one, and if you wanted to be thorough, I would accept this one. But technically the 1 is not needed because you must always have 1, and it's implied. Okay? But this one right here is the most correct, and that's the one you would see utilized in papers and whatnot and all that. What in the... Oh, that's lunch. Woo. Okay.